Hi, let's continue with section 7.5, graphing f of x equals a times x minus h squared plus k. So let's talk about a little bit of what we know. So if you may recall, we talked about quadratics, and we know quadratics are equations that have a highest degree of 2. So we have an x squared. We learned the general form, which is ax squared plus bx plus c. And with that, we've learned how to solve, find intercepts, and now we're going to build our knowledge so that we can graph. Now this new form is called, well, I've seen it called different things depending on the textbook. It's called standard form for some, standard form, or it's sometimes called vertex form. Now, the reason why we like this method, or I'm sorry, this structure of our equation, is because it tells us so much without us having to look out for more information. A lot of things are just given. So what is given? Well, one of the important things that's given is the vertex, hence vertex form. We always have the vertex as h comma k. And the vertex, as we'll talk about in a little, it's just that peak in your figure. So if you have some parabola, your vertex is that low peak, or if it opens down, your vertex is that high peak. And we'll talk about those a bit more. All right, so this is what this section is about. Knowing all the different changes that happen to this U-shaped figure, or as your textbook calls it, this cup-like figure. Okay, so for your homework, go to My Lab and Mastering to complete it. Shifts of parabolas. We have learned that we have learned that parabolas when graphed create a U-shaped graph. This graph can open up and down, or down. It can also be shifted to the left, to the right, and up and down. This U-shaped figure can also be made skinnier or wider, and that's what we'll learn in this section. Let's begin with the vertex. The vertex is the peak of the parabola. When the equation of the parabola is given, it is what's called vertex form, is f of x equals a times x minus h squared plus k. The vertex can also be found, easily be found. It's h comma k. Notice that the h is negative in front of your equation. So when we pick out the vertex, the h value is always the opposite sign from the equation. And we'll see that in examples. Let me just give you all this information first. We also have the axis of symmetry. This is called the line of symmetry. This is where the U-shaped graph is cut in half from the vertex. It is a vertical line, and the equation of the axis of symmetry is always x equals k. And that k comes from your vertex, h comma k. Now, axis of symmetry, let me give you a quick drawing. If we have a U-shaped figure with some vertex, the axis of symmetry cuts it in half. And that's a very special feature because it lets us graph things and cheat along the way. So if we have a point here, then this point is also going to be right here as well. And the reason why that is so is because it's symmetric. So we have on one side of the line of symmetry will also be on the other side of the line of symmetry. Let's talk about a shift, vertical compression or stretch. A graph of f of x equals ax squared or y equals x squared, ax squared, is a parabola with x equal to 0 as it is a line of symmetry. Its vertex is the origin. For a greater than 0, the parabola opens up. For a less than 0, the parabola opens down. If a is greater than 1, the parabola is narrower than the x squared. If a is between 0 and 1, then it's made wider. So let's talk about those numbers between 0 and 1. So we have fractions. We have, for example, like 1/2, 1/4, 99 over 100. So if we have a fraction that's between 0 and 1, we have a wider graph. So let's say this is our general graph. If I have a fraction, I'm going to have some wider image of it. Now, right above, we say that if the number is greater than 1, so like 2, 3, 4, then I'm going to have a skinnier graph, more narrow. And I think I have a picture up below, right? So we see our line of symmetry, and we notice that here we have a fraction, and notice how the line is wider compared to our x squared graph. We have 2x squared, and we see that it's more narrow. So in other words, if I have a fraction between 0 and 1, then it's wider. If it's greater than 1, it's more skinny, or we say narrow. Horizontal shift. Horizontal shifts happen in the parentheses. That H is your horizontal shift. The graph of f of x equals a times x minus h squared has the same shape as the graph of y equals ax squared. If h is positive and the graph is shifted however many numbers h is, h units to the right. If h is negative, the graph is shifted That's wrong. So if I have a plus h, that means you move to the left. If I have a minus h, you move to the right. Well, maybe it's not saying from the parentheses. I think that's what it means. Okay, so moving forward, here we see that I have a minus 3, so we move to the right 3 from the graph. Here we see we have a plus 3, so it's like having two negatives, so we move to the left. Vertical shift. Vertical shift is exactly, let's sum it up. It's exactly as it reads. So your vertical shift comes from this k. If I have a plus k, then we move up. If I have a minus k, then we move down. So here we have a picture how we have a graph, and if we add that minus 5, it moves each point down 5 units. Reflection over the x-axis. There are two rules to keep in mind for this. If the leading number is negative, then it opens down. So if I have like negative 2x squared, I have a parabola that opens down. If it's positive, then it opens up, like 2x squared. Note that if a parabola opens up, the function value or the y value of the vertex is a least or a minimum value. If the parabola opens down, the function of the vertex is the greatest value or a maximum value. And that would make sense as we have here. If it opens up, then we have a low point. That's a very special point in our graph. And if it opens down, we see that we have a peak that's higher. All right, let's do some examples. Graph f of x equals x minus 4 squared. Did I forget the 2? 2 times x minus 4 squared. So we know a lot. For example, we know the vertex. Our vertex is always hk. Now remember about the h, it's always the opposite sign. So I see a minus 4, my vertex will be a positive 4. Now I don't have a plus something, so we have 0. Your line of symmetry is always x equals h. So whatever h is, that's your vertical line. our h was 4. All right, so I have an important piece. I have a line at 4 comma 0, and I have a line of symmetry right along that line. The vertical line x equals 4. Now I want to graph this U-shaped figure, but I want to be as clever about it as I can. And by clever, I mean less work. So because it's symmetric, I know that I can find one point and kind of transfer it over. Also, I want to note that we don't start with a negative. So then our parabola opens up. It will look like this. All right, so let's pick a point to test. Let's test a point like 3. Let's see where 3 is. So let x equal 3 and plug it in. So I want to find f of 3, which gives us 2 times 3 minus 4 squared. 3 minus 4 is negative 1 squared. Negative 1 squared is just 1, so I get 2. So I have the point 3 comma 2. Let's plot it, which is right here. Now, because we know we have a symmetric graph, I'm going to have that same point line up right here because it's 1 away from our vertex. And that's enough to graph. So here we have our U-shaped figure, and we know it opens up. There we have it. All right, that's it for our shifts. Let's write a quick summary. And by quick, I mean super quick. Let's write it right here. We learned that we have a vertex at h comma k, and that h is always going to be opposite sign. We also have an axis of symmetry at x equals whatever this h is. We also talked about shifts. So using this equation as a reference, we know from our shifts that if I have a minus h, I move to the right. If I have a plus h, I move to the left. And that's counterintuitive because we think right as positive, right? But it's kind of switched. If I have a minus k, I move down. If I have a plus k, I move up. All right, that's a quick summary of shifts. That's it for this section 7.5.